Welcome to Math 1324. This is section 8.4 on Bayes formula. Now, at first, before we get to Bayes formula, we want to remember some things about fractions and how to simplify them. So in question 1 here, you see we've got this multiplication on the top. We've got this multiplication and addition on the bottom. So if you like, I can put some parentheses here. So we're going to multiply and then add together. On the top, I've got 7/3 times 6/7. 7's cancel. 3 into 6 goes 2 times. All right, so this piece is a 2. This piece is a 2. 1/3 times 1/6 is 1/18. All right, so we're at this part here. Now, I need to be able to combine these two fractions. So I need to convert the 2. So 2 is 2 over 1. Multiply top and bottom by 18, so I get 36 over 18. 36 over 18 plus 1 over 18, and I get 37 over 18. Now, to simplify this situation, you take the top fraction and you multiply it by the bottom fraction flipped over. So nothing reduces here, so 2 times 18 is 36 over 37. All right, easy enough. All right, in question 2, we want to find the probability by looking at this tree diagram that they gave us here. So there's a probability for M, there's a probability for N. Those add up to be 1. From M, you could get A or B, and again, those add to 1. And similarly, going away from N, those add to 1 as well. So they want us to find the probability of M and A. So where is that? Well, here's M and A. So we simply multiply the probabilities down that particular branch. So the probability of M is 0.4. The probability of A, given that I'm on the branch of M, that's 0.6. And so multiply it together and we get 0.24. Okay. So in the following, it's a bit more complicated. We want to find the probability of B. Now, where is B in this picture? Notice B is on the end of 2 branches. So to find that probability, I have to trace down each of the branches that take me to B. Okay, so I need M and B, N and B. So each of these is just multiplying down that branch. And then to find the total probability, I would add those two probabilities together to get 0.5. So let's try to remember something. The probability of A and something, which we just used, is the probability of A times the probability of B, given that we are on the branch or A has occurred. Now, we could solve this formula by dividing everything by the probability of A, and so I get something that looks like this. So trying to introduce Bayes' formula now, let's look at a picture where I have urn or jar 1, urn 2. And in these urns, I've got 3 black, 2 white, 1 black, 3 white. So how did I get all these probabilities? Well, someone told me that the probability of picking urn 1 is 1/3. The probability of picking urn 2 is 2/3. In urn 1, there's 5 total things and 3 black. 2 whites out of 5 total. And in urn 2, I've got 4 total. So black is 1/4, white 3/4. So what if I wanted to find the probability of urn 1 given black? Well, what is that? Well, go back to this formula. So to find it, I need the AND of this and divide that by the probability of B. Okay, see, it's the second part there. Well, the probability of B, remember, I had to go down all the branches that led me there. And so it would look like this sum on the bottom. And if I expand the top, we get this formula, which is Bayes' formula. So that's the probability of urn 1 given that I know I have a black. All right, so let's look at this picture over here. In this picture, in question 4, I want to find the probability of urn 1 given red. All right, well, let's see. How many things are in urn 1? Well, there's 20 and 10, so 30 total. The 20 that's here, what is that? Well, that's red, intersect urn 1. So that's the 20. Here is the number in urn 2 is 70 total. And this little piece in here, the blue piece, the 30, is U2 intersect red. How many in all of S? Well, add up all the numbers and we get 100. So to find the probability of urn 1 given red, I go to Bayes' formula. Probability of urn 1. All right. Probability of red given urn 1. And then on the bottom, this sum. So let me go up a little so we can still see. So let's see, probability of urn 1. Well, there's 30 total in there out of 100. Let's see, red given urn 1. Okay, there's 20 reds out of 30 total. This number still appears here on the bottom as well. All right, and what's this? This is the probability of urn 2, which is 70 out of 100, and red given urn 2 is 30 out of 70. And so we can reduce all that. So the 30s cancel. 20 out of 100 reduces to 1/5. These 70s cancel as well, and so I get 3/10. All right, so how did I go from there to there? Well, let's see. I decided to get a common denominator of 20, and you'll see why in a moment. So I multiply top and bottom by 4 to get 4 over 20 in both places. Top and bottom there by 2. And so I've got 4 over 20 over 10 over 20. All right, so when I flip this, these cancel. and 4/10 is 0.4. All right, so in question 5, we want to again use Bayes' formula. So I want to find the probability of W given I have a C. Well, let's see. Where is C? C appears down this branch, and this branch. So there are 3 branches to get to C. So this denominator has got to include all 3 branches. All right, what about the probability of W? All right, well, that's this branch, which is 0.5. Probability of C given W, all right, that's the 0.1. On the bottom, I have to do the probabilities for all of the branches to get to C, and then add them all up. So I've got 0.05, 0.1, 0.06. All right, from there it's fairly straightforward. Add the denominator. I can convert this to 5/21, which is this long decimal. But they said round to 3 decimal places. So the thing after the 8 is a 0, so I can throw all this stuff away, and I get 0.238. All right, in question 6, we have, first off, we have 2 urns, and one is as likely to be chosen as the other. That's a key word here. What that means is the probability for urn 1 or urn 2 is exactly 1/2. All right. What's in urn 1? Urn 1 has 1 white, 3 red. So the number of things in there is 4. So the probability of white is 1/4, red 3/4. Urn 2 has 4 things in it. The probability of white is 2 out of 4, so 1/2. Probability of red is again 2 out of 4, which is 1/2. So the probability of urn 2, given that I have a white. All right, so I'm going to have to sum 2 branches to get to white. So here's a white, so I need this branch, 1/2 times 1/2. I need this branch, which is 1/2 times 1/4. Let's see, the probability of urn 2 is 1/2. Probability of white given urn 2 is 1/2. All right, so what do I get? Let's see. Well, I've got 1/2 times 1/2 on the bottom, all the branches, so 1/4 on the top. I made this a 1/4 of 2/8 because I'm adding it to 1/8. So I get a 4th over 3/8. Flip the bottom. And so 4 goes into 8 2 times. And so that probability is 2/3. All right, question 7. Again, we have 2 urns. One is as likely as the other. That's why these are 1/2. Urn 1 has 1 white, 6 reds, so 7 total. Urn 2 has 7 total as well. 2 white, 5 red. So you see, that's how I got all these probabilities for the branches. You really can't do this problem unless you make the tree diagram. So what do I want? I want the probability that I picked urn 1 given that I'm holding a red. All right, so I'm going to have to sum all the branches to red. So 1/2 times 5/7, 1/2 times 6/7. That's the bottom. Got that there? And the top, probability of earn 1 is 1/2. Probability of red given earn 1, that's this part, which is 6/7. So I get 6/14, a 6/14, plus 5/14, so 11/14. Flip, the 14s cancel, and we get 6/11. So it seems complicated with all the notations and the symbols, but the real secret here is make the tree diagram, fill in all your probabilities. The bottom is always going to be whatever branches you have, tracing down them all, adding them up where you've multiplied the corresponding probabilities. Enjoy!